Oh, we're getting to some cool approximations now. We're going to use trapezoids to approximate the area between the curve and the x-axis. So this is yet another way of approximating area. And so we've got f of x equals root x, the x-axis, and x equals 4 here, and x equals 0. So we're finding the area here. We're approximating it. Now we're going to use trapezoids. Now, to do this, instead of memorizing a formula, a lot of teachers will just say, here's the trapezoidal approximation formula, memorize it. I do want you to memorize something. That would be the area of a trapezoid, which is given by 1/2 the height of a trapezoid times the sum of the bases. That's it. That's how we do it. So anytime we do these approximations, you can always factor out a 1/2. Now, like in the previous Riemann sum problems, we're using the same exact curve again, so we can make comparisons. Notice that the intervals are the same. Remember that this is your a value and your b value. The number of subintervals, or the number of rectangles we use, is your n value. And so therefore, what we have is delta x is still the same thing. It represents something different, though, in the trapezoid. I'll show you shortly. It's still b minus a over n, which in this case would be the overall width of 4 minus 0, all over the number of, now not rectangles, but in this case, trapezoids. So before, as I mentioned earlier in this video, it's about the number of rectangles. Now it's about the number of trapezoids. So that would give us a width of 1. All right, how does this come into play? Let me show you how these trapezoids are formed. It's very neat. Whoever came up with this is brilliant. So if we take a look at this curve right here, a trapezoid would be formed by looking at your delta x. That's actually right there. That's going to be the height of your trapezoid. And then the two bases extend up to the curve. Now this first base has a height of 0. And we just connect the dots. So that's actually going to end up being a triangle that first time. But you'll see the trapezoid come in now. And I'll do this in a different color here. So this next one, you've got the height of the trapezoid right here, right there. And then here's the trapezoid. The trapezoid comes from the two heights in the curve. There's another height and another height. And now what we do is we connect those two pieces. Oh, it's a really nice approximation, right? Isn't that awesome? And then a width of 1. So I think you're starting to get the hang of this here. So we get that. These are the two heights of the next trapezoid. Notice that the height of this trapezoid, the base of this trapezoid overlaps with that trapezoid and that one. And the final trapezoid, here's the height right here. So we've had our heights. And the base of the trapezoid, we have one of the bases is here, the other one is there, and we connect those. Notice that our trapezoids are just slightly under f of x. Because these end up being secant lines, so they're just slightly under that. More on that down the road. Okay, so how do we find the area of each of these? Well, remember that in a trapezoid, just in general, and I'll draw it out oriented like what we're seeing it here. In a trapezoid, the height of any trapezoid is the perpendicular distance. So the straight line that makes right angles with the two bases. So this would be the height. So in our case, that's delta x. Each of those is the height. So delta x is the height. 1/2 is just part of the formula. The bases would be, we'll just call that f of x1 plus f of x2. The bases are always going to be here and here. And in that case, that's your f value here and your f value there. That's it. So let's go ahead, let's rock this. I'm going to factor out a 1/2. Right? I'm going to do that from everything, because each trapezoid will have a 1/2. And now I go to the first trapezoid. I know it's a triangle, but just riddle me this. The width here, the delta x is the height of the trapezoid. So that's 1. So that's your delta x value, right? Times, what are the heights? F of 0 plus f of 1. That's it. That's your first trapezoid right there. Think of it as base 1 plus base 2. B1 plus B2. That's all there is. Plus, what's the next height? 1. That's delta x. Times, what's base 1? Well, that would be the height here. That's f of 1. So that'd be the height of the curve. And then base 2 of that trapezoid would be right here. That's f of 2. Oh, starting to see how this is forming there? Notice the overlap. It's the same number here because f of 1 was both the base of the second trapezoid, the first trapezoid, as well as the base of this second trapezoid. Plus, and I'm going to have to spill over down into here, 1 is this width, times, this will be base 1, base 2. That would be f of 2 plus f of 3. F of 2, f of 3, base 1 plus base 2. And finally, the width of the last trapezoid is 1. That's right here, times, And now we've got B1 and B2 are f of 3 and f of 4. So you see why there's always that overlap. I like to split this into separate trapezoids like so. It makes more sense to me. Trapezoid 1, 2, 3, and 4. Now, I'm going to come back to you after some terrible video editing, right? And I will give you the answer. How am I going to get that answer? I'm simply going to plug each of these numbers into the square root of x. That's all. Be back with you in a jiffy. And as promised, there's that terrible video editing for you. It's humorous, come on. What I did is I just plugged in the numbers, because you didn't need to watch me do that. I literally took 0, plugged it in for root 0. That got me 0. Root 1, f of 1 is 1. Root 2, and I just replaced each of those values, and then did my calculator work, simplified it all down, made sure to multiply by the 1/2 for my formula, and I got 5.146, which is a solid estimate. We know that that's between the left-hand estimate of 4.1 and change and 6.1 and change. Is it the exact area? No, but it's a darn good approximation. What we'll do later on in this lesson is I'm going to be going over how to do these problems when the information is given to you in a table of data. It's really sweet. But I hope that both the left and right Riemann sums, the midpoint sum, and the trapezoidal sums are easy for you. Keep them as basic geometry problems. That's my advice. And add up areas of simple geometric figures. And you'll be in good shape. I'll see you next time. Peace.